Right, I think we're live. Hello everybody to another day where we try to make a game engine, full-blown 3D game engine in Golang from scratch, more or less, almost. Maybe take a minute for people to come, but I think today we'd like to finish setting up the GUI. Maybe I'll just start to preparing this. So let's see, where were we last time? SDL OpenGL 3, right? And we had this open, so we're trying to implement basically the OpenGUI renderer, right? And we succeeded, but then it does not interact with us in any way. So I think this is what we'll do today. We'll try to get everything up and running so we can actually drag around, click, and whatnot in ImGUI. So we kind of get back doing this, open up our main.go on this. There we go. So we have this, it doesn't click, it's not draggable, nothing, but it shows, right? And we had also our movement, our MVP model, the view and projection matrices. So we can see this kind of shape, 3D shape, and we can move around, right? So that, yeah. And interestingly, the horrible lag we were having last time went away when we tried to build a run, right? And it turned out that it was actually building pretty quickly, but was getting stuck on init for some random reason. And the restart of the computer helps. And now it's basically instantaneous. A few seconds and that's it. It doesn't take forever. Because getting stuck on init for so long. Yeah, it's pretty quick. So the whole thing is 7, so maybe 5 or 6 seconds to build around. One good thing for us is to also say, I think, runtime dots localhost thread. And what's happening here is, unfortunately, but we'll work around that in the future. But we cannot, due to some limitations in how kind of these windowing and rendering systems work, we cannot switch to a different thread when we're rendering. So if we did, for example, this is our initGL, right? Init OpenGL. If we init here and we get then the window context and whatnot, it's we cannot move to a different thread and then also call OpenGL calls. We must continue to do OpenGL calls on the same thread that we started on, which is this, right? But that's a problem once we want to multi-thread, because if we have another thread that wants to do some rendering, how do we get it here? That should be kind of straightforward. We can keep the rendering on one thread and then have something like a channel where we send over data from other threads over to be rendered on this thread. So we only ever render on this main thread, but the rendering commands can be issued from any other thread. So we can multi-thread safely and keep one thread dedicated for rendering. That should be a pretty good solution, I think, for a very long time, if ever we need to do it. Now, one other thing that happened since last time we had this is someone was using nMage on Mac and they couldn't get it to run, and that showed us a few bugs that were actually fixed. They're not merged yet, so I'd like to talk about them so we can fix them first. Now I'll come we can start the ImGUI stuff. So what happened is, turns out, and I made a branch for this. Turns out that on Mac or recent Mac devices, Apple only supports OpenGL up to version 4.1, not 4.6. So this, along with one or two other bugs, essentially in how we init OpenGL, made it crash on Mac. You couldn't run the app. You couldn't run nMage on the Mac. So those are fixed, and I tested it personally, at least on the M1 Mac, and they work. It works fine. So we're just going to change these now before we do anything else. So essentially, we want to do version 4.1. We only have one over here. We use it in the buffers. There we go. The data. In the shaders for sure. Why go does that? Does it like us changing imports? Okay. So change this to all 4.1 so we can have kind of a minimum support going. Right, cancel. Right, so I think that should be it. We can confirm, and then there are a few more things that we need to do. Some calls that are not available on anything below 4.5, which we will know now. So that's fine. And see, we get a crash. We should. So Windows does support everything. I think Linux as well. They do support all the latest OpenGL, but not Mac. Right. So you kind of have to, at least in this case, support the minimal platform. One other thing you could do is you could detect which platform you're on and then use the appropriate libraries. That's also possible. Okay, are we again taking forever? Or potentially because we just changed, so it's like recompiling all the stuff. Well, whilst doing that, we can look on some stuff. So I think there are multiple calls. So we have create buffers and there's gen buffers. So let's take a look at create buffers, right? OpenGL. So if you look at that, create buffers was only added in 4.5, right? So now that we switched to 4.1, we can no longer use create buffers. The thing is, as far as I understand, create buffers, the only difference is create buffers actually generates the buffer and binds the buffer, right? It's kind of a simplification. The more classic approach is you do GL gen buffers, right? Gen only generates but doesn't bind anything. So wherever we do create buffers, we just change it to generate. Let's see, do we have create program? I think fine. What do we have? Create shader. I think these are okay. This is still compiling. Oh, it's actually wrong. Okay, so this is okay. Let's see the commit they did, just to make sure that we're not forgetting anything. So on Mac, I don't think we want to update dependencies. Yeah, maybe I didn't push on this branch. That's fine. I should have. That's very weird, but that's okay. All right. So we did that, and then do we have anything else? This should make sure that anyone is using Mac or a device that doesn't support the latest OpenGL, then nMage should still work. Okay, so bind buffer, gen buffer, so this is fine. We have create buffer now. So this should be it, I think. And we switched everything to 4.1 core. Cool. Yes, let's just confirm again that this runs. Let's go. And perfect. Now that this is done, we can start looking into ImGUI again, I think. Let's do that. So we're looking at this last time where they created a platform, like initialized. Actually, just before this, there's one more thing we should do. In this regard, Windows is very kind of forgiving. We're still working on Mac. This would crash, and the reason is we did something, right? It's something very stupid, which here it says these attributes, which we tell SDL. We tell SDL about what we want the window to have, and it must be called before the window is created, right? This must be called before the window is created. While init, it's a long one, but should be with an active context. And so if we look at what we're doing, we're actually initializing init, creating the window, and only then, so after the window is being created, we are initializing OpenGL, which obviously is wrong. So what we would like to do is all these attributes, set attribute, I think even clear current needs to be after, but anything with SDL needs to move. So I think we can move this. Right, so take this, or we can keep this here. We can make a new function. Init SDL. You can move all of this up. Let's make this 4.1, and then honestly, even this should be, let's take all of this as well. Take this. Let's return an error here, and just kind of that should be it. That should be good. Now, so we have init.stl, which we are doing all of this before any window. That's correct. So let's do null. Return. Cool. So we have this. Now we create the window, and then we get the GL context. And only after we get the GL context can we init OpenGL, which now only does this. Because as this says here, this must be called under the presence of an active OpenGL context, right? Which we did. And then we can set GL commands afterwards. Cool. Here I can type today. Return. Right. Let's do a similar API here. So you can say return error, otherwise it's return null. Let's handle this up. If error it's not null, then we want to do this. Or this one we just crash. We should still run. All normal. Let's see. Cool. So all is good. And this should be all the changes I made to get to work on Mac. This is actually now more correct code than we had before. So always read the docs, people. Don't do this. All right. Let's see. So SDL is done. Now we can go back and discuss what do you call it? ImGUI. So ImGUI, if you remember last time, we needed a bunch of information for ImGUI. It's essentially a full rendering system by itself. It needed all, just like when we render any objects, we did need all the VAOs, the buffer objects, the vertices, whatnot, to render ImGUI. So we are getting all the vertices from the ImGUI library, and we just have to render it ourselves. So in the beginning, we're setting up everything that we need. So we set up ImGUI, we made a struct to hold all of this, right? We generated the needed buffers and we stored them in these structs, and then we uploaded kind of the font that we're using. And finally, we enable the attribute used by the ImGUI shader, right? So far so good. And then at the end, so in our game logic, we now have a place to kind of update ImGUI. We put all our UI here, and then so this, then we ImGUI render to signal that at the end we say, hey, we're done drawing ImGUI, right? We're not drawing it, but we're done sending you commands. You can prepare all the vertices for it now. And then when we come to draw, we draw it at the end of everything. So we draw all our kind of objects in 3D scene, and then we draw the UI. And drawing the UI, we are setting a bunch of GL options every time. We have our orthographic matrix. And then, and I think I also fixed this. Let me just check. Yeah, this should be a correct version. So we can use GGLM now instead, which we'll do in a minute. But then we have our orthographic matrix for ImGUI, and then we just kind of set all the information, we set the attributes, and finally we draw, right? We get everything, all the data, vertex by vertex for everything that ImGUI wants us to draw for it, and we just draw it on the screen, right? We bind the texture, bind the buffer objects, and then we draw elements. One thing is we don't want to do some magic numbers here. What we want to do, orthomat, right? We want to use our own nice library. So let's do orthographic. Let's do something similar to this. So I think left is 0. Is it? I think, yeah. And right is win width, right? And then top is 0, bottom is win height. And I think that this was the place where we were going wrong last time. The math was actually correct, but ImGUI draws exactly at 0. So the near clip to the camera, it draws basically above everything else. So the near clip must be 0 or even something smaller, right? But if we put it like 0.1, ImGUI stuff is behind this near clip. It's exactly at 0, and so it's never drawn. So if we put this, we will not see, and this is what was happening last time, we're not seeing the ImGUI stuff. So we need this, and the far clip really in this case doesn't matter. We can put 20 just to make sure it kind of works. And this thing is commented out, and we can try until we get this thing to work. So yeah, you can see our mistake here from last time, which we did here again, but we put the 0.1 as the near clip, and ImGUI is behind it, and it's clipping here. Right? So let's bring this back, but this time we have our ortho matrix. We set it, so now we should not see ImGUI, just to confirm that our kind of logic is correct. Yeah, it's gone. Now, if I make this 0, I think it should work. There we go. Nice. So now we can use GGLM without any magical matrices here. Go away. Thank you very much. And here have this. And really, since it's always the same matrix, we don't need to update it. We can have it as a global variable, but for now, I guess it's fine. We do need to update it when we change the window height and height. That's so we can do perf, which is really update ortho matrix on window reset. Right. Cool. So we're at a good position now. I think we have this stuff going on correctly. Right. So what we can start looking at is how do we send events, like click events. So now I click on this, it's not doing anything. What we want to happen is when we click, we want to see this click message. Right. So let's see how to do this, and this is our goal for today. Hopefully achievable. Maybe for one time we would finish the stream without it going for too long. Right. Platform. So let's look at SDL. I think this has a bunch of stuff. And then let's look at the OpenGL 3 render. I don't think render will have a lot to do today. But yeah, but definitely the platform. So let's look. There we go. So that's one thing. So let's just walk through the code first, see what they're doing. They're doing any magic stuff. So SDL, so you can see they're looking the thread in its window, set key mapping. Okay, so they set key mapping and then set some attributes. Okay, and then yeah, nothing interesting here. Right, so platform process events, display size. So let's look at mappings. Okay, so these are SDL, sorry, ImGUI kind of things. So ImGUI has its own mappings for keys. And then we are kind of saying, okay, these are the ones that you map to. Perfect. Okay, and then we send it. Interesting. To io.keys down array. Keys down. Where is this io.keys down array? io.keys. No idea, but let's take this as our starting point. So this is done on init. So maybe we can do it when we init ImGUI, at least for now. So after all of this, init input code, right? For ImGUI input mapping. Like this, right? So we do use the same. I mean, we should eventually tie it to our input library, where we used. We did also use SDL key code with a key state. But yeah, but still SDL key code. So I think this is okay. So tab, arrow keys, insert, enter, and then a few keys. Okay. All right. And then we loop over them, and then we say key map. Oops. So here we have IMIO. Come on. There we go. They have this key map. So what's key map? Maps a key into key downs array, which represents your native keyboard state. Native key and ImGUI key. Okay, so we'll see what this does. But we're just telling it this key of yours maps to this code. So I assume later on we're going to have to send these codes to SDL. So in processing, okay, so like for example a mouse wheel, we send this information to ImGUI. Okay. Let's see, where is this used? Text input. So whenever something is clicked, key down, text input, key up. Interesting. Okay. Modifiers and key release. Makes sense. It even has modifier keys. Cool. So let's start with this then. So in our processor, let's add these. So right now we have key down and key up. And we do need to think a bit about how we want to maintain this separation between our input layer and kind of ImGUI. But for now, I think we just plug it in here. So in keyboard events, mouse events, keyboard event, yeah, okay. So you can plug it in here. So we do notify our input system. We also notify ImGUI. So ImInfo, I think we called it, yeah, ImGUI info dot ImCTX set current, get current. Why is it not giving me stuff? Weird. Oh, ImGUI get context. Okay. Okay. So we can say, so let's take this here. IO is ImGUI dot get current or current IO wait, and then this you can say IO thing, and this is a verb. So we have key press, and we need to handle key release, key down, key up, get type. We can say if e dot type is SDL dot what do we have? Key down, right? Else if key type key up. Right, so this is in key press, and this thing is in key release. ImGUI has a really nice API, honestly. People do praise it a lot for being really good, but I think I kind of get the idea. It's very clean. Makes a lot of sense. Rendering and also the even the input is very smooth. Okay, so here we do the state. Yeah, STL.pressed. Okay. I wonder if there is a difference between get type and type. Nope. Exactly the same. So you can just keep it e.type, key down. You can potentially use this to simplify the input layer. That's for later. We care about it. Okay. Do we handle mouse? So mouse click, but not mouse wheel. So we can actually just take this, add it now, so you can have scrollable mouse event. Right there. So e.x. This is very simple. Essentially, if ex is bigger than 0, then we kind of increment or decrement. Same here, and then we set the delta. So where have we moved, in which directions, left and right? Some mouse devices do have kind of a click you can do to the left or right on the wheel. So this is the X, and then the Y is pretty standard. Did we move up or down? And that's it. Okay. Awesome. Text inputs. Maybe we can do this. So I assume this still counts as a keyboard event, I think. We can check, but yeah, let's do SDL.text, text input, and it's the actually no, does it? It's keyboard event. Well, yeah, it's a different thing. So then, so let's have SDL text input. Text input event, right? Okay, let's plug this in here. That should be it. I don't know. It would be amazing if this is all text. If I'm going to take events, it's a lot simpler than the rendering part. Oh, yeah, let's see. We don't need this. It's just E. That's it. So we're just copying the text. We're sending it to ImGUI. Modifiers we can look at later. Don't think set important now, so we can just do a to do send modifier keys, e.g. control to ImGUI, right? And even for our input system, we do need to kind of handle those. So, do we have anything else? It doesn't seem so. And here I don't expect we'll need anything, honestly. Let's see. Let's try and see. What am I doing? Okay. Nope. Still not happening. Interesting. Okay. It's never that simple. So what did we miss? Pretty sure we missed something stupid. Well, okay, these are fine. I assume we don't need these. And we did all of this. We did the key map. Set key map, which we did at the end, right? And we know we are calling this because we do see the render. Cool. Let's see. Okay, mouse position. All right, that's important. And mouse click. Yep, this we need that. So we don't miss click release events. Short frame. Okay. So they're doing it at the initialization of the frame. Yeah, which we can do in the end of the input event. So because this happens just before our game logic, which is essentially where we do this, but they're doing it after. Okay. Well, just before handling the logic. So after this, but before this. I'm not sure if it makes a difference. I guess we can try. I wouldn't like to mix that into the game logic, but let's see. Maybe we can separate this into kind of a frame start, frame end thing. But let's keep it simple for now. So we have our IO. Button down. We don't care about this. And set button down. Yeah, I mean, we are doing this in the input layer here. They're mixing this input code with that. I think we do get mouse state. Do we? Mouse wheel delta, handle mouse event, and here, yeah, we do all the state magic. Yeah, I mean, you have a position, get mouse events, mouse. Yeah, in position. Oh. Okay, so we're not doing position yet. Let's do that at least. This one. And then I guess we can query. We can query our own input system for these three buttons. So we set the position, and then we say, we tell ImGUI if we have been clicked or not. So we can say maybe, what's the code? Set mouse down, index, yep, allow buttons. So I assume it's left, right, yeah, left, right, middle. Okay. So down, is this down so we can query our nice input system? Mouse clicked, Mouse down. Yeah, mouse down, not mouse clicked. Okay. Mouse button. So MB. Yeah, mouse button left. How do we say that? I'll completely over. Button left. Is it button left? I think so. I think so. Left. Nope. Button ends. Wait, okay, there we go. So button. Yeah, we do need some we do need some better enums here, but let's do button left, button right, and this is 0, 1, right? That should be it. States. Don't think okay, what and that be it is channel. And we're telling it where the mouse is. Ooh. Oh, it worked. And we can drag stuff around up to the edge of the screen. How cool is that? So we have highlights. So now ImGUI knows when the mouse is over, we do get these events when I click, I drag, and I assume, there we go. Resize the windows, and yeah, nothing crashes when I do it too quick or anything. Resize. Yes, we can. Yes, we can. How cool is that? Oh, this is weird. Maybe some viewport stuff. I don't know. Oh, completely out. Why are you doing this? Okay, we do need to look at this, but yeah, so there is a shift between the mouse position after resize, or maybe after maximize. I'm not sure. I am not sure. Are we not handling? So maybe we're doing resize events, but not what do you call them? Not maximize. So let's look at that. Dun, dun, dun. Not game logic. Events, actually, yeah. If it's not resized, we continue. So let's see what all the types we get are. So maybe we can print line type is either type. And unfortunately, this is just a uint, but we know that this is 5. And we can say maybe, what else is it? Okay, there we go. It's probably 8. So maximized equals 8, just so we don't forget. Resize. So let's see if we get a maximized. So many little things to keep track. Okay, why are we getting maximized? Okay, so it's not bad. Some 512. We don't know what this is. Let's maximize. Nope. Why are we getting 512? So far no drift. Click works. Maximize. Yeah, broke completely. Oh, we're not getting anything? What? That's very weird. What window events exist? Enter, exposed, focus, gained, moved, move to the map, resize, restore. I am not sure. You can try handling it. So this should be okay, even if it's not this, and window events. Let's see. Otherwise, you can check the STL docs. Okay, this is good so far. Nope. Yeah, that's not going well. But I do think a normal resize always works perfectly. So if I resize this, a lot smaller. No, actually, this broke as well. This is odd. Yeah, it's the game broke, so it's not just about maximize. Wow. Okay, this is something to look at, but yeah, at least it's something. So we have interactivity. We can actually start having UI, and I guess this is the start of an editor. Once we want to do that, is essentially just having a bunch of ImGUI windows, and you have all this nice features. I think they even have docking. You can dock stuff, and you have a system like Unity or Visual Studio which can dock different windows. All right. So this thing, we change the projection matrix, and we set window width and height. Sure. I would like to know what 512 is. Let's see. These are in order. Okay. Interesting. Lost, gained. These are all something else. Window. Oh, okay. Maybe these. Window event and just window. Okay, maybe. So we have 512, which is input. Okay, input focus. All right, we don't care about this. We don't care because there's a Vulkan. Okay. So something going out of sync. Stay. Mouse position being reported wrong for some reason. Is the GL viewport wrong? Let's see. So we set it every frame because we're drawing. Or that we have to set this after, like, in the same place they had it. So let's try this. So let's take this and move it all the way here, just before new frame is called. I think this was done here. Yeah, just before new frame is called. We set this. I'm not sure if this will do anything, but we can try. Who's giving me a yellow? We don't care. All right, let's try. See. Okay, so the basics were fine. Cool. Scale. Yep. Yep. Debug. That is a weird shift. Okay, let's report. Let's put this back. And so how about every time, let's maybe log the mouse position. So let's do line or format logging or info logger or printf. So let's print. Mouse position to this, and let's put XY. Right. What else? So I would like to know also the window size. So maybe yeah, Yes, let's do mouse position, and then window size is, then let's do width. Yeah. All right, let's run. They should match. So when we get to the edge of the screen, the mouse position should be kind of the window size. So 0, 0 is top left, okay, and then bottom right should be. Yeah. So this is being reported correctly, and that's why we can interact with this correctly, right? This is right now. If we scale a lot, this breaks it. Oh wow! So we didn't update our window size. What? Our window size was not updated. At least the variables weren't. The window size does seem correct rendering, but okay. I think we forgot to update the variables in here. Actually, we didn't. Win width, win heights. So they're being set. Interesting. So we know the issue, kind of, is that these variables are going out of sync with the actual window size, which makes no sense, but it is what it is, I guess. Okay. This one, it is the global variable. So then maybe let's log a message whenever this happens. Okay. So let's say printf window. Potentially we need to just handle more events. That's all. Window resize 2, and you can say using, yeah, because I at this point it's weird, but I don't trust win width and win height because for some reason they're wrong. So let's just log also edata1 and edata2. Just to see. Yeah, look at that. Some interesting problems we're getting. All right. So we have this no resize so far. We resize. Oh, all right. We're not doing that work at all. This is never happening. Amazing. Okay. So window event, then what? It's not resized. Size changed. I have no idea what resize. I have no idea what the difference is. Okay, as we resize to data 1 into data 2, it's always preceded by window size change. Size changed. Okay, either by an API call or through the system or changing window size. This event is followed by window event resized if the size was changed by an external event like the user. Okay, it does seem dangerous to do this because it says even an API call, so I'm not sure. Like if we set the size, does it actually like make us call the thing again? I don't know. Right, let's see the docs. Let's see what the docs say. Okay. In screen coordinates, sure. Not very useful. Okay, let's see. So window event size changed. see if we get it now. All right, so resize. Nope. I don't get it. How are we not getting any event? I case SDL events. So display event, okay. OS sensor, text editing, event, window event. That is very weird. So let's print then another message. Window event. And the event is e dot type. Yeah. So the type, let's see everything. We're actually getting kind of somewhere where we're slowly having more and more of the pieces you would need for a proper engine. So GUI, you can draw stuff, shaders, windowing. There is still a lot more to do, but it's somewhere. And I would like to show off one of the next streams, the import system, because it's pretty good now. I actually managed to get Asm to work in Golang, and we have most of the API, most of the core API implemented for importing stuff. So you can actually import most of the stuff we would want, like meshes and normals and all of that, and post-processing. Once we integrate this with nMage, then we can actually load any model we would like and just show it on the screen without specifying vertices or colors by hand. Should be very cool. Okay, so no matter what I do for this, which is what we have to fix first to get there, I don't get any events. I have no idea. All we get is window event 512, which is input focused. Although, ImGUI is maybe doing it right. ImGUI is scaling. Window events. Yeah. So you always end up here. So then let's look at SDL2 window resize. Resizable, okay. Set window size. And GL viewport, sure. Window event, if it is window event resized, let me do this. I don't get it. So we should be getting these events, because just like GL viewport, we usually do want to do some things, even if resizable is handling all the magic for us. Missing, we should get a callback, an event telling us that this happened. And so we have this we never reach. So we never update our projection matrix. Interesting. I used to think, I thought this was working before. That's okay. We can figure it out. So set size is this. We never reach here. Window events. event ID, padding, and event data. Saying this in the docs. To resize event. It's being shown. Okay. Yeah, but we don't get anything. Poll event, and then window events, window ID, and so on. Okay, so it's none of that. We are actually not even getting the event in the first place. Okay. Event watch. All right. Yeah, I mean, we can get an event watch at least to log things. So, is I think basically telling SDL call this function whenever you get an event. Right. So then, in this case, let's just check in. You have this event watch. Yeah, add event watch. Add event watch function. Filter event filter. Get event filter. What's that? SDL event filter. What's an event filter? Event user data. Let's say we don't want filter, just send me everything. And user data. Oh. As a callback to be triggered when an event is added to the event queue. So added to the event queue before being processed. Okay. Same value. Okay. Not really helpful. Okay. Let's check this. Right, so move. I don't see how any of this is helping. Let's do set size. Okay, let's just see if the window itself, at least automatically, is updating the size. So maybe every event okay, so at the beginning, maybe let's log the every frame. Let's do logging. Info logger print line printf size. Let's just log the current window size. So we say window get size. Yeah, get size. And let's run and see. Let's also move this. Everyone good? Is everyone following along? Fine. All right, let's look. Okay, so we're getting the starting size. Let's change this. Yep, it's definitely getting resized. We're just not getting the events for some random reason, which maybe we can leave for another day just to figure out for what stupid reason we're not getting anything. But we can detect this and do the events ourselves for sure. Either this, or what if we remove the resizable? Can we? We remove resizable, does it allow us to do things? I don't know. We can try. ImGUI pop-up shown. Let's see. So if we remove this resizable thing, what happens then? Otherwise, for now, we can detect the change between two frames and detect it and change it. Yeah, it's not allowing us to resize at all. And drag it. Yeah, so we need that. Right. So in that case, we can say well, the last frame size is just this, so I don't think we need an extra variable. So in this case, perhaps at the end, right? Maybe at the end, it's right here. So if our window height, right, or window width, let's do this. Width. Current window height, so we get both, and if the width or height changed, either of them is not equal, then we can take essentially all of this resize code and move it into its own thing. So let's copy this. Copy this thing. Note, SDL is not firing window resize. It is resizing the window itself. Instead, let's make function window handle window resize, right? And if any of these is not equal, then we can call handle window resize, and we can send in the new updated, I guess, just new height, new width, right? And both are is it an int? What's wrong here? Come on, stop complaining. I think it's an int. Let's see. Yeah, it's an int 32. And we can say current width, height. That's it. Now, first, let's update our variables. It's new width. New height, and then we can update our projection matrix, and that's it. I think there isn't anything else to do. And then everything, all the calculations going forward should now be more accurate because we do use this window width and window height to do things. So all of these things were not really accurate before. Right. For now, let's log the mouse position and the window size. Make sure everything is right. See? This works, then we should have properly resizing window along with ImGUI. So now it's interesting, we lock the main thread when we drag. Crazy. Okay, so mouse position is now correct. So from 0, 0 all the way to window width, window height. And I can drag this around, click it. So shrink it. Ooh, now this seems correct. Yep, no drift. And you can see the mouse. So the mouse position when it's at the bottom right is exactly basically the window width and window height. And because we're now properly updating our projection matrix, you can see we don't see this this kind of shrinking and blurring of both the UI and the object. You see the UI remains consistent no matter what I do. I shrink it and the UI remains the same size because now our calculation for the UI is correct, and the object, you see, remains the correct size as well. I don't think it should be moving like this, but yeah, there's a problem we can see later. I am not sure. There's a small tiny drift. Yeah, this looks good. This looks correct. This is working and clicking. Perfect. This is nice. So we don't need this anymore. This is all good. We should update the viewport when we resize, and then we don't need then to update it every single time, because right now we're updating the viewports every time. Yeah, we don't need that. We can move it to where we handle the window resize. So we can do this and get these things. A new window. I am worried about what happens when we minimize it. Do we also get the 0? But yeah, the drawable, like the frame buffer width and height, will definitely change. Yeah, then we can update the viewports. Or you can try. Let's run it and then kind of shrink it and see how it goes. So right now, we stopped logging. So let's log. Right here. Print line. Really. Logging info printf. Right. One size is this, and then FB size is this. One width, one height, and then frame buffer width and frame buffer height. It's okay. So nothing so far. If I resize, there we go. So they're the same because I don't have kind of high DPI screen. Maybe on a Mac it would show. But yeah, this is so far correct. If I minimize, we don't get, we don't get a resize. If you do this, yeah, it's still still on 0. There is still 1. Can we make it 0? Can I crash it? Nope. Yeah, I think this is the minimum get to. Right. So this is good, I think. And then we update the viewport only when needed, so we don't do extra driver calls to the GPU. Then we update these. Perfect. So we have ImGUI. We have full GUI implementation. Very cool. I would like to try an input box just to make sure that we can actually, write stuff on it. So just click. So in here, maybe let's say if ImGUI, but I don't know what's called, input text maybe. So name. So let's do var name string, and let's put the name here. I wonder when this turns true. So let's say maybe every time we enter a character. So if we have both of these working, so we know we have keyboard events, we have mouse events, we can drag stuff. That was good. Nice. ImGUI is really cool. Nice. Let's drag this, make it very big. Okay, so I have cursor. Awesome, and I can delete. No modifier keys yet. Well, yeah, I can use the arrow keys. Then, okay, this is. Ooh. I wonder if we should limit this, but it's okay. That's my fault. Anyway, so when do we get an event? So yeah, so every time we click, we do something. I guess you could use this for input validation, for example. Awesome. While we're at it, why not handle input, right? Yeah, it's fine. Okay, so now that you have this, maybe we can go ahead and where is our layer? There. So our modifier keys. So where's this? Key up. So on key down, key up, they're doing modifier keys. They have a bunch. Left and right. L shift. And yeah, clipboard we should handle also later. All right, let's do this. Get mode states. Is our input system handling them? I would like to know, because if so, we can just use it. So let's do handle inputs and input mouse down. So we can say maybe print time control, and let's do inputs dot key down STL dot control. Yeah. Key modifier masks. Okay. This or this. I don't think we can use this, so we need to do this. I think def control is okay, and mode is def control. Oh, okay. They actually point it to, no, they don't point to the same thing, so we cannot use them interchangeably. All right, so control, and then we say true or false, right? Left control. If we have this, we're good to go. So it's false. Oh, it's maintaining its size. Crazy. I didn't know that. Okay. Go on, ImGUI. All right. Yeah, so we can detect modifier keys. Great. So we have left control, and then in that case, you can take these along with the mouse. Just these ones, and map modifier. What's map modifier? What is this modifier function? Oh, okay, this one. So it's essentially taking the mask and creating a key output. We don't need that for now. We will just accept one set of keys, right? And here SDL k underscore left control. What's this, by the way? Sorry, this is shift. So this is shift key shift, left shift and the right shift. All right. So in this case, what did we map it to? Let's see. Anytime GUI, see our map. So we have tab. Do we have shift? No. So it's not actually in the thing. But I guess we can continue to use scan codes. Let's do scan code, left shift and scan code, right shift, and that's it. And again, left control, right control, then left alt and right alt. Let's see if that works. Okay, so I think if I type something now, yep, it's definitely working. So now I'm holding control, and I'm sorry if this is too small, but I'm holding control here, and when I do the arrow keys, I can jump between words. So the control is being sent. Otherwise, I can just do it normally. I can delete full words also. Great. So this is working. I would love to move all the kind of ImGUI stuff out of the input, but it is kind of part of the input as well. This is done. Do we have any other to-dos? Yeah, these. Resizable window, moving camera. Once graphic is fixed. ImGUI integration is done. Asset loading, it's not done in nMage, but it's done in Asm. So we'll do that. Timing we need to get soon. For now it's fine. And yeah, buffers will need to, because I think this is enough for today. Pretty good job, I guess. Bit ugly to have everything here. Maybe we can move this. Where do we use ImGUI stuff here? This one. Yeah, I mean, I think for next time, maybe move, or let's say Struct UI, right? So I want to move this into its own place and have it kind of its own package, and then we don't have to do low-level stuff or know about, okay, I am IO or things like that. We just init the package and send it events just like we send to the input, just how we say input.handle blah event. We should be able to do, this thing. So get most event or get key event, etc. That should be good. Name is here, time. Yeah, perfect. This thing we don't need. All right. Yeah, so ImGUI, and then all of this. So let's just make sure one more time our scaling is working. The next time, I guess we can abstract it and potentially start on model loading. I would love to see something else compared to this, or maybe lighting, just basic lighting. Yep, clicked. Awesome. Looks good. Looks good. Maybe very quickly, if we can, in our fragment shader, I would love to have some lighting, because this thing is just like a white block that shows nothing. So the simplest kind, I think, is use lighting. Yeah, it's relatively simple equation. Yeah, where we just kind of have like a point light, and the places facing the light get lit, and then the places behind, the more away from the light it is, the darker it gets. Oops, sorry. So ambient is just kind of the environment. So it's not like a light pointing. Kind of what's the minimal we're going to get. Yeah, it's just a multiplication by the color. I don't know. Maybe we can have it. There's nothing wrong with that. Let's go. Oh, one thing, yeah. We do need to change our shaders to be version 4.1. It's working now because Windows does support 4.6, but it wouldn't work elsewhere. All right. So in our fragment shader, so usually we did our work on the vertex shader, where we're dealing with the object itself, with the vertices, the position. But once we want to do color, we do fragment shader. So perhaps we can have, and this is potentially a good place for a uniform, but keep it simple and quick. So ambient, so it's kind of our ambient light by some light color in this case. So let's say it's a vec4, I think. So ambient light color, right? So what's our ambient light? What's our default light in the environment? Let's say it's kind of a weak light, so no alpha, but very dark color. And then we can take the pixel, what the pixel was supposed to be. So let's say the pixels are supposed to be white, so we can keep them this way. I think we can multiply. Now, of course, all of this will go away once we have, once we load the models, and then we can actually have proper colors going on. But object color multiplied by the ambient color multiplied by the ambient strength. I think. What's wrong? Why are you sad? Anything is. Oh, okay. Vec4. Let's do this. Let's see. Ooh, you can't see it. Probably there. Way too dark. So let's do this. So we don't want to scale this part, right? So Yeah, so let's make all these vec3. We don't care about alpha. Alpha, we want alpha to be there because that's our transparency. And so let's make this a vec3, and then the object color again, vec3. But in the end, when we come to do all of this, we put it in a vec4. These are all like vec3s multiplied together, so component twice, so x with x, y with y, and z with z. In this case, RGB, right? It means RGB. And then here we put 1.0 for the output. Or maybe, yeah, you can just see it, right? So you have, this is like the most basic type of lighting, where we have the ambience, and this is a good place if we make it uniform, and then we have a slider on ImGUI, and we can control the lights. That would be very cool. But for now, this is good. And then let's get some very basic diffuse lighting. Should we do it now? Yeah, we don't have normals. We are not doing that. That should wait until we load the objects. Okay, so then we can just do, let's say we have a red light, right? A red ambient light, and kind of half strong. So when we multiply, our object is white multiplied by kind of a red light at half strength, and that gives us what do you call it? If reddish, should give us a reddish color on the object. There we go. Nice. Very weird, but yeah. And if we really want to get fancy, then these things would be like, let's say we make this a uniform, right? Load, which starts at 1, and in ImGUI, since we have this now, ImGUI.slider, I think we have a slider for floats, ambient vector strength, right? What's our float? So we can say, hey, it's ambient color strength. Strength is starts at 1. Right. Then every time we get this, we do minimum is 0, maximum is 1, and this is a load 32, right? So if this got changed at all, what do we want to do? So we want on our simple shader to set uniform. So we don't have that function yet, might as well add it. So we want to set uniform 32, right? And here we just do value dot 32 program uniform 1f, right? And then we just give the pretty simple dot 32. What's our uniform name? It's ambient strength, and the value is this. That should be enough, surprisingly, to have a control. And this is one of the best things with ImGUI. If you do it early, is you kind of get the ability to make changes on the fly without restarting kind of the engine. So we have this. It's very bright because our ambient is 1. It's reduced. Get a very cool effect. This very, very nice. What would be cool is let's do also ambient color. That's GGLM like 3, right? And amazingly, ImGUI does have this. So slider dot 3. Let's take this. I'm sure ambient color values. Okay, so we do have the ambient color data. Should be able to just get a pointer to it. And then minimum is 0, maximum is 1. Then if we do ambient, so set uniform vec3 ambient color, and our thing, so this value we can move it up as well, and we say this is a right. And this is essentially what materials are. If you have used Unity or something like that, where you kind of have all these sliders. So you have a shader, you choose a shader for a material, and material system is something we'll work on soon, I hope. Material is essentially a shader with a bunch of uniform values. That's more or less it. So one material can be shared by multiple objects if they all have the same values. But if I want the same shader to have different uniform values, then I have to create copies of that material and give them to different objects. Now, this is good. So we take it. I hope this data call works fine. And we set it only when needed. Okay. It is called ambient light color, but otherwise it's good. Let's see. Okay. Okay, nice. So we have 3 sliders. This is very cool. Let's get this closer to us. So it's right. So now we have full red, green, 0 green, and 0 blue. And let me take this up. Right. So let's do, if we do all of these, get white. Nice. This is yellow, which is red and just green. And we can mix and match and see kind of the effect. So this is, we have a white object and then a light coming in, and the 2 colors are mixed. Right? And if everything goes, it just becomes black. And this thing is because our object itself is being multiplied by a light color of 0 or a strength of 0. And yeah, and this is white, so it's taking the light of the environment. Now, if we have a different color for our object, we're going to get kind of, by multiplying, we kind of mix those. Yeah, I think this is a good stopping point. Very cool vertical progress. We can finally actually see things and do things that are interactive. It's starting to feel like a game engine. I think once we have asset loading and we can do complex objects and then some at least basic lighting, we wrap that into some nice objects, and then we can start making a simple game and kind of see how things go. Yeah, cool. It's very kind of addictive. Anyway. All right, everyone. Thank you all for coming, and I'll see you next week.